All right, Trig. We started out in today's class talking about the values around the most common triangles, the 30, 60, 90 and the 45, 45, 90. And so you need to be very familiar with these two triangles. To go from the short leg to the hypotenuse, you double it. To go from the short leg to the long leg, you multiply by radical 3. Likewise, going backwards would be division. Same thing with the 45, 45, 90. Both are side lengths the same because it's an isosceles triangle. And to go from the side length or the leg length to the hypotenuse, you multiply by radical 2. Likewise, going backwards would be division. And so we looked at the two right triangles if we had a hypotenuse of 1. Your 30, 60, 90 with a hypotenuse of 1 and 45, 45, 90 with a hypotenuse of 1. Cutting it in half and multiplying it by radical 3. So you'd get radical 3 over 2 and also 1/2 for that leg. Taking 1 and dividing by radical 2, you must rationalize. You would come up with radical 2 over 2 for the side lengths. Now keep these two triangles in mind because we're going to be using them a bunch. Now I need to kind of go through and remind you about the unit circle, and we're going to do so in degrees first because you're used to that. Okay? So let me zoom in here on it, and then we'll take a look at it. We've got, trying to make sure it's not twisted. Okay, a 30-degree angle. We're going to move around the circle in increments of 30. 30, 60, 90, 120, 150, 180. Of course, that was 0. I should have put that one on there. 210, 240, 270, 300, and 330. So I can split a circle up into 30-degree increments. I could also split it up into 45-degree increments. So for instance, this is a 45-degree angle, this one right here. And then another 45 would be 90. And another 45 would be 135. And then another 45 would be 180. And another 45 would be 225. And another 45, 270, and another 45, 315, and lastly, we'd be back to 360 degrees. Now, I want you to see the 45, 45, 90 right triangle. Right there is a 45, 45, 90 right triangle. Now, maybe I should outline the edges a little bit so that you could see it a little bit better. And if I was only smart enough to use a marker before this situation occurred, but I'm not, so you just have to watch me and get mad at me. Right, Ducker? So, there is your triangle. This is called a reference angle. A reference angle is the angle drawn to the closest side of the x-axis. So when you're dealing with a 45-degree angle, which is quadrant 1, then that's a 45-degree reference angle. But that 45-degree reference angle could also be seen in this particular triangle, the one over at 135 degrees. And that triangle can also be seen down here as a reference angle for 225 degrees. And that reference angle can also be seen over here for 315 degrees. So if you draw the triangle to the closest side of the x-axis, you can find the reference angle. Now, what about the 30, 60, 90 right triangle? Once again, I'm off screen coloring the edges so that you can see it better. And I know you're making fun of me right now, especially you, Armstrong, I'm sure. That's okay, he's not watching the video anyway. So, there is your reference angle for a 30, 60, 90 right triangle. Right? That 30-degree reference angle is the same as that 30-degree reference angle for 150 degrees, which is the same as that 30-degree reference angle for 210, which is the same as that reference angle for 330. But this triangle could be used to find that angle right there, the 60 degree, or the 120 degree, because that reference angle can be drawn straight down to the x-axis, or in this case, for 240 degrees, straight up to the x-axis, or for 300 degrees, straight up to the x-axis. So the 30, 60, 90 right triangle and the 45, 45, 90 right triangle really helped me kind of figure out all kinds of stuff around this circle. Now, what kind of questions could they ask me? Well, they could ask me things like, what's the sine of 60 degrees? The sine of 60 degrees. Right? And I would have to give the exact answer for that. Exact value. Well, let's take a look at our picture here. Maybe even zoom in on quadrant 1. A 60-degree reference angle. Now, what's sine again? Sine is the y value. Look at the triangle. This has an x value of 1/2 and a y value of radical 3/2. So the sine of 60 is right here, radical 3/2. It's the y value. So in order to answer their question, my exact value answer is radical 3/2. What about the cosine of 240 degrees? A cosine of 240 degrees. Well, take a look at the circle. 240 degrees is down there. Do you think it's the 45, 45, 90 right triangle? No, definitely not. Or the 30, 60, 90 right triangle? Well, there it is. 30, 60, 90. Now, cosine is the x value. Now, I see that the side length here is 1/2 in the x direction. But I also notice that we're moving to the left of the x-axis. That must mean that the x value is negative. So, negative 1/2 is the x value. So when they ask me for the cosine, negative 1/2. What about the tangent of 330 degrees? Tangent 330. Well, come back to my circle. 330 is down in quadrant 4. The angle measurement drawn up to the x-axis would be, looks like another 30, 60, 90 right triangle. The tangent, we remember, is the y over the x, the sine over the cosine. Well, the y value here is negative 1/2, right, because it's below the x-axis, divided by the x value, which is positive radical 3 over 2, right? If you look at that side of the triangle, it's positive radical 3 over 2. And I'll just zoom in and make sure you can see the triangle. So let's see here, that's negative 1/2 times 2 over radical 3. 2 divided by 2 is 1. So that's negative 1 over radical 3. Of course, we want to rationalize that, giving me negative radical 3 over 3. So, what are the coordinates of the basic points in quadrant 1? Well, based on this triangle, this is a radical 3 over 2 for x and a positive 1/2 for y. "60 degrees, since it's based on the same triangle, would have a 1/2 for x and a radical 3 over 2 for y. Now, does it make sense to you that the x's and y's are switched? 30 and 60, what do they add up to? 90. Those must be complements to each other, and that verifies the complements theorem. Well, the last one remaining there is a 45, 45, 90. It has an x value of radical 2 over 2 and a y value of radical 2 over 2. Now, what do you get when you divide those? What would the tangent be equal to at 45 degrees? Anything divided by itself is a 1. The tangent here, 1/2 divided by radical 3 over 2. Well, we just kind of did that one a few seconds ago. Right? The tangent for that would be radical 3 over 3. And what do you get when you divide? You've got radical 3 over 2 divided by 1/2. That's the same thing as radical 3 over 2 times 2 over 1. So I'm left with square root 3, tangent of this one equals square root 3. Those values right there, based upon those two triangles, will get you everywhere around this circle. And I do mean everywhere. Alright, now, I could ask you some questions, simple ones like, what's the cosine of 225? Now, which one of those triangles would we be dealing with there? I would say a really good clue would be the fact that it ends in a 5. 225 is down here in quadrant 3. So the triangle that we're using is the 45, 45, 90. So we're looking for x according to this. Cosine is the x. So we're going left, and so this would be negative radical 2 over 2. Using my triangles, I can go anywhere around this circle. Now, I also need to talk to you about this triangle, these triangles, in relationship to radiance. This whole circle. I can start this circle over again, the unit circle, but this time I'm in radians. And I want to kind of show you how I would jump around the circle and divide it up. Now remember how the last time I went in increments of 30 degrees? Well, this time I'm going to go in increments of pi over 6. So, because we know that pi over 6 is equal to 30 degrees. That's 180 over 6. Okay, so we've got 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6. Now remember, I'm jumping every 30 degrees around the circle. And this was 0. 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, and 11 pi over 6. Lastly, 12 pi over 6 gets me right back to the beginning. So, we have hit almost all of the major points around the circle. Some of them can be reduced. For instance, this is 1 pi over 3. This is pi over 2. This is 2 pi over 3. This one, just plain old pi. 4 pi over 3. 3 pi over 2. 5 pi over 3. And lastly, 2 pi. And that's a complete revolution, but we already knew that. So, you'll notice that there are 4 points that I skipped. Those are based on the 45-degree angle, or pi over 4. This one is 1 pi over 4. Then I jump another 45 degrees to 2 pi over 4. And then 3 pi over 4. 4 pi over 4. 5 pi over 4. 6 pi over 4. 7 pi over 4, and back to 8 pi over 4, which is 2 pi. Those are the radian measures. Now, I'm also going to ask you the same types of questions in terms of sines and cosines and all that good stuff. But this time I might say, okay, what's the sine of 7 pi over 6? Now, you need to know your unit circle in radians, but it's still based upon this triangle. Pi over 6 is a 30-degree angle, right? 7 of them would put me 1, 2, 3, 4, 5, 6, 7. And that is the 30, 60, 90 right triangle. If I'm looking for the sine, which is the y value, it's a negative value, obviously, because it's below the x-axis, and it's this side of the triangle, which is 1/2. So, we've got negative 1/2. What about the cosine of 5 pi over 3? 5 pi over 3. 5 pi over 3 sits down here. Drawing it up to the x-axis creates a 30, 60, 90 right triangle again. Or, as we say in the math in the radian world, the pi over 6, pi over 3, pi over 2 right triangle. So it's got an x value based on 1/2. It does move to the right, so that's positive. So this is the positive 1/2. You need to know your radian measures. What I would do is practice going around your own circle just like I did. Split it up into sixths. Split it up into fourths. If you want to, do it on separate circles. I need to be able to look at a unit circle like this and ask you questions like, where do you find 4 pi over 3? Which letter represents 4 pi over 3? Which letter represents 330 degrees? Which letter represents negative 7 pi over 6? So you need to be able to answer those questions. Which one is, okay, my first one was 4 pi over 3. Then I had 330 degrees. Then I had negative, I'm going to mess this up. Negative 7 pi over 6. maybe I need to find 17 pi over 6. Maybe I need 9 pi over 4. Or negative 11 pi over 3. You should be able to find these places on the circle. We'll talk about these in class, so make sure you can find them. Identify which letter is which so that you can do this, whether we're in degrees or radians. I know you're more familiar with degrees, but you need to get used to radians. Okay? Use the idea of the triangles, whether it's the 45, 45, 90 or the 30, 60, 90, to work your way around the circle so we can answer more questions in class about those particular values. And practice answering some of these types of questions where you're just looking for different values, cosines or sines. Go online, find, oh, I gotta go to my webpage. There is a link on the Trig on my Trig website. There's a link. Click on the link section, and I found a web page that will allow you to practice some of these things. It's it's at hotmath.com, but make sure you follow the link so you can go right to the page, and then you'll choose. And I think I wrote in there which one you need to pick. So, talk to you tomorrow.